Welcome to today's webinar. The topic today is new features of concrete design add-on for RFEM 6 and RSTAB 9. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the Dlubal website, the German and English webinars, newsletters, and so on. I will be the moderator today and answer your questions together with Alexander Meyerhofer and Adrian Langhammer. And Paul Kieloch will present the webinar in RFEM 6, but my colleagues can introduce themselves.
Hello, my name is Paul Kieloch. I'm a product manager and customer support engineer at Dlubal Software. And today I will show you new features in our concrete design add-on in RFEM 6.
Good afternoon, also from my side. My name is Alexander Meyerhofer. I'm the head of product engineering concrete. I'm working in the development of the concrete add-ons and also in the geotechnical analysis products. I will answer today your questions in the chat.
Yeah, hello, my name is Adrian. I'm responsible for the customer support and especially there for the concrete design. But I'm also responsible for the development and there especially for the testing of the program and for the topic construction stages. And I also will answer your questions today.
Okay, thank you for your introduction. Then we can switch off our webcams so that the attendees can see the full screen. For the attendees who participate the first time, you can show or hide the control panel on the right side of your screen, and you can enter a short question here, and we will answer you. If there are too many questions, sometimes at the end of the webinar, that happens sometimes, and we can't answer all questions, then you will get an email after the webinar. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's all from my side. I hand over the screen to Paul. Paul, it's your turn.
Okay, thanks Andreas for the introduction. I will start with a short overview about the content of today's presentation. So, as I already mentioned, I will show you today new features in our concrete design add-on. Therefore, I will create a small structure in RFEM 6. And during the modulation process, I will tell you all the new features which we have now in our concrete design add-on. Just a short overview about these new features. Mainly it's the automatic function for surface reinforcement. Then we have also a new function regarding determination of required reinforcement for members, which includes now also the serviceability limit state design. Then I will show you how to design with member representatives. We have also a new multi-edit option in the edit member dialog for members and member sets. If we have entered a reinforcement and we have a certain reinforcement layout inside our member, then we have a new function for printing graphics of this reinforcement template or proposal into the printout report. I will show this also to you. And I will show you how to activate the design check for this shear joint in the add-on. In general, if you would like to know whether we have new features implemented in our software, you can switch over to our website by using this link here in this presentation. Or you can also sign into a Dlubal extranet, and if you switch there to the development, then you can filter the product add-on concrete design, and then you see all implemented new features and a list of them. Okay, with that words, I would switch directly to RFEM 6. And as I mentioned before, I will start with creating a new model. Therefore, I'm opening a new model file. And what I would like to do today is starting with a template that has the benefit that there are some settings stored already in the template, and also add-ons can be activated, or I could predefine here some national annexes and so on. So this is already set in this template, and I would give the name here a webinar, and maybe English, so that's the English one. And I start this file here. And as mentioned, due to the fact that I've used these templates, I have here a certain amount of materials, sections, thicknesses, and so on. And I will use them today for this presentation. So at first, I'm switching here to these guide objects, and there I will create a new line grid. And I will use or show you today also the labels here and the dimensions. Switch here over and enter the dimensions in X directions. In X direction, 5 meters and 4 spans. So it looks like this. And in Y direction, the first span with 5 meters. Then I have 2.5 meters and 2 spans. And the last one is again 5 meters. So this is my line grid, which I would like to use today. It looks like this. And on this line grid, I will create my slab and my beams and columns and so on. So I can switch off the grid in the background, and then it's a little bit cleaner if you just see the line grids. Okay, the first topic is entering a surface for design. So I'm creating here a concrete surface with the thickness of 250 millimeter and this concrete here. And before I'm entering this surface, I can directly set the design properties for this slab. So concrete cover and the concrete durability clause, I leave it as it is by default here in this example, XC1. The reinforcement direction is also default. And I will consider here and assign here a basic reinforcement for the whole slab with a diameter of 10 millimeter and a spacing of 15 centimeters in both directions. You see here already some changes in this dialog, and I will come back to this changes and modifications of this dialog here in this latest version of RFEM 6 later after the first calculation. Okay, I can confirm this. The design configurations, I leave them also by default for this first attempt here, and I will also come back later to these design configurations. The last thing I'm changing here is the reference length for the deflection analysis. So I switch this to manually, and the reference length is now here set to 5 meters. So I have 5 meters in X and Y direction, and I switch this manually to 5 meters. Confirm with OK, and then I create here my slab. So by default, you see here also the rendering of the assigned reinforcement mesh. And what's new now in RFEM in the latest version is here the description of the assigned reinforcement. In the latest version, we changed it a little bit. In the previous versions, there was a small arrow downwards and upwards. And if the arrow was downwards, then it was the reinforcement on the bottom side. And if it was upwards, then it was the reinforcement on the top side of the slab. That was now changed a little bit, and it's just a small line next to the text on the downside or on the upper side. So it's a small change here. What I would like to change is here the number of decimal places for this example. Okay, and now I'm switching off this reinforcement just to have a cleaner look on the file or on the structure. Okay, perfect. So the next topic is that I would like to enter a beam here or a rib member in this axis D. Therefore, I create a new member, switch the type here to rib, and I'm assigning this eccentric cross section on the positive Z side of the surface. That's a setting by default. And the used section should be this 250 by 500 millimeter section. Can confirm that is okay. And then I will assign this rib here in this axis. And here in this axis 3, in this point in the middle of the beam, I would like to support this beam with a column, and therefore I'm dividing this member here by one internal node. But what's new in RFEM 6 is that we can use this node type on member, and that would have the benefit that our member is not divided in two parts, and that makes it a little bit easier for definition of reinforcement and so on. So I will create a new node just with the type on member without dividing the member. Okay. And you see this here in the middle of the beam with a blue, light blue node, and that's the new type for dividing members. Okay, the next steps I would like to do is entering here nodes for the column heads. So they are here in these points. Okay, and now I'm switching to the wireframe display model, and I can select these 5 nodes here, and then I will copy them with 3 meters in Z direction, and I can link these steps here and enter automatically a new member. Therefore, I will create a template. The columns should be hinged at the top end and the bottom end. So I'm switching here the member type to truss. The section is pre-selected in this case, like I would like also to use it, with 250 by 250 millimeters. And I can now go through all the settings, all these design properties here, and entering, for example, the buckling lengths for the stability analysis. And in my example, it's a braced system. And I would like to use these effective length factors of 1 in both directions. Okay, next step would be the concrete covering. I leave it here in this example like it is. Regarding the shear force, I would like to use shear links with a thickness or diameter of 10 millimeter and a spacing of 15 centimeters. And the longitudinal reinforcement should be uniform surrounding, 4 rebars and a diameter of 14 millimeters. Okay. Design configuration and design supports are not required to change here in this case. So I can confirm this. And then I'm using the template to create my columns. And they would look like this. I have just to take care because this node is here in the center of this eccentric beam. So the nodes and at the bottom end are not in the same height. I will just do a double click here on this node and switch this to 3 meters. And then we have the same level here. Okay, then I can create the supports for these columns due to the fact that I have hinged member ends by this member type. I can create a new nodal support, and this is fixed or rigid in all directions. That would look like this in this example. Okay, then the next topic would be entering the support at the edge of the slab. So there I would like to consider walls. Therefore, we have also an option in RFEM 6, so I can select all the lines at the edge of the slab, opening them with a double click, and I will assign there a support, create a new one for them, and this one will be changed to local. And as soon as I switch this to local, I'm getting here a new option, stiffness via a fictive wall. And the wall thickness should be 25 centimeters and a height of 3 meters. And it is hinged at the wall head and base. So that's okay for me. Can confirm this. And then I have also the lines on the edge of the slab supported. If I would like to check this graphically in my system, then I can switch to the view or display navigator. And there under the line supports, I have the option to activate the walls. And then I would see the system also with this fictive walls here. Okay. That is basically my system now. What I have not defined yet is the settings regarding the RIP. Therefore, I'm opening the RIP member once again. And I switch to this tab here with the RIP. And in this table, you can basically assign the segment length for the determination of the effective width for the RIPs. I will not go too much into detail for this part. We have shown this in our first webinar regarding concrete design in November 2021. And it's also part of the Eurocode 2 training where we get more into detail regarding this table. I will just enter the values here to have a realistic, realistic effective width for this example. I'm using here this approach according Eurocode 2. So I'm setting the segments here. Okay. Eurocode 2. Then, okay. User defined. It's the same on the other side. Basically, I have to do this because I'm using one member which is supported in the middle, and therefore the program needs the reference length. Okay. So the system would look like this now here. So I have different effective widths here in the fields, left and right field, and over the column I'm using a smaller width, and the width is determined by the equation according to Eurocode 2. What I can now also here assign is a linear distribution here over this column, over the support in the middle. So therefore you have the option to assign to end and from start, and then I would get here a linear distribution of the effective width. So that's what I would like to use today. And I will stay here in this tab, because here is now already our first new feature. You find here in the middle the option to activate the design check for the shear force between web and flange. So if you would like to perform this design check, then you have to activate this option here. And then you get the settings regarding the roughness of the surface. You can set it here up in this dialog. And there is also a second setting in the configuration. I will show it to you in some minutes. So next is the section tab. There I do not have to do any changes. This is okay so far. Concrete covering also. So I can directly switch to the shear reinforcement. I would like to use here shear links, stirrups with a diameter of 10 millimeter and a spacing of 0.5 meters. And I will not use this for the whole length of the member, but I would like to have a span in the middle of the beam where I have 10 centimeter spacing between the stirrups. So therefore I'm creating new spans. First switch here to absolute for the definition of the span length. Then I just click 2 times on this button. And then I'm getting here these spans. If I zoom in a little bit, then you see that here this middle span is now a little bit displaced and not in the middle of the member. And I can change this here to 6 meters. And in the second X location to 9 meters in my example. And then the span is in the middle of the beam. And I can change this to 0.1 meters or 10 centimeter spacing. Okay, that's my shear reinforcement I would like to use today. And then I'm switching to the longitudinal reinforcement. By default, the reinforcement is using here 3 rebars at the top side and on the bottom side. I will change it to 4 rebars. And then you find also here the rebars from the surface reinforcement, which is automatically also assigned to the flanges of the rib member. If you do not want to assign these surface reinforcement here, then you can switch it off via this button, but I will leave it on here for this example. Last thing I would like to add here is an additional reinforcement here on the sides of the web. So therefore I'm creating a new item. And this one is a uniform surrounding for my example here. And uniform surrounding. And 6 rebars with a diameter of 12 millimeters. And then I have to enter here an offset from the stirrup. And from the top side, it's 150 millimeters. And on the bottom side, also 150 millimeters. And then it looks like this. Then I would consider these 3 rebars on each side of the web here for the reinforcement. Now, if you have entered the shear reinforcement or the longitudinal reinforcement like this, and you would like to print a graphic of this definition into the printout report, there is also a new feature. You can click on this button here, and then you get a new dialog called reinforcement layout. And in this dialog, we have here a new button, a new function, and there you can print the graphic here directly into, for example, the printout report or 3D PDF or a graphic as a file. So it's not a CAD file, it's a picture file. So you have this option, basically the same like for printing a graphic, regular graphic into the printout report. So that's also a new feature in the add-on. Okay. Then I'm switching to the tab with the design configurations. There we have the ultimate configuration and the serviceability configuration. And in both configurations, we have now 2 new features, or in every configuration, we have 1 new feature. If I'm switching to the ultimate configuration, then you can see here this shear joint, and that is what I have activated before in this tab with the rib. So in general, there is always the shear joint design check activated, and there you find further settings, for example, how the program determines the shear stress in the joint, or you can also activate here design of flange connection on segmented cross section. So if you would like to perform these design checks, then you can check it on here in this ultimate configuration. So just keep in mind, this is always active, but you have also to take care here whether you have activated the shear joint in the individual members. The next new feature is inside the serviceability configuration. So inside the serviceability configuration for the members, you find here a new option, determination of longitudinal reinforcement for members. We have implemented this in the end of last year, and now it's possible, if you check this option on, to consider also the parts from serviceability limit state in the result diagrams for the required reinforcement. So in the older versions of RFEM 6, there was just the ultimate limit state considered in the diagrams for the required reinforcement. And by activating these options, the diagram will also consider the parts from the serviceability limit state. If you click on this here, then you get here a little tooltip. And there you see that currently this option considers the requirement for the minimum longitudinal reinforcement, the design check for the limit diameter, or the maximum spacing. So the direct crack width calculation is currently not implemented. Okay. That's so far regarding the new features in the configurations. One last topic I have to enter here is the or the design supports. In concrete design, we are checking the deflection in Z direction. So I'm switching here over local Z axis. And if I zoom out a little bit, then you see that the member length is 15 meters. So this dialog basically does not know that we have here a column in the middle of the member. So the reference length would be by default the total member length, and for the deflection analysis that would not be okay in this case. So I have to enter here design supports to consider this correctly. I'm creating here a new one, monolithical, with a width of 250 millimeter in my example. That will be assigned at the start and the end of the beam. And then we have also one here in the middle. That is an inner support, also 250. And as soon as I have assigned these design supports to this internal node here, then you see that we have two spans here, each with 7.5 meters. Okay. We have defined our reinforcement for the member. And the next steps I would like to do, or next topics I would like to enter here with the structure, is a FE mesh refinement. I would like to assign the FE mesh refinement here on these nodes. So I'm selecting them, double click FE mesh refinement, and I create a new one that should be rectangle in my case, and I'm using here a inner length of 7.5 centimeters. Okay, so it looks like this, and I can now, if I have assigned a image refinement, also use here in this situation a surface result adjustment to use average values of the surface internal forces. And therefore, I'm going to the special objects here, and there you find the surface result adjustments. So I create a new one for the surface 1. I will use here dimension in A and B direction with 0.75 meters, both directions. And with this button, I can set the first location. And then if I click on apply, then I can just show you where this is located now. I'm just using this button here for copying this assigned surface result adjustment. And then it's pretty easy to create them, just clicking on copy and switch the location. It goes like this. Here. Okay. And if I click on apply, then you see them here in my file. Okay. The next step would be to enter the loading. So before I'm doing this, I just want to check whether my structure is correctly entered, whether there is maybe some problems regarding F-image and so on. Therefore, I would just calculate the first load case here. And yeah, that looks okay. Everything seems to be connected properly. And now I can show you also, if I switch here to the internal forces of the surfaces, how the surface resultments are working here. Yeah. So everything seems to work. And now I can switch off the results and the F-image maybe, and I can switch also of the surface result adjustments that are here, the result objects. And I'm also switching off here type for nodes, the nodal mesh refinements. And then I have a cleaner look on the file. Okay. Now I can start with entering the load. At first, I need some new load cases for this situation. So my first load case will be the load case for the self-weight. I will call it just the L for dead load. And then I will create new one here, live load and 1 maybe. And I'm using this category. And I'm copying this. And then this one is live load 2. This one is live load 3. And this one is 4. Okay. Apply. The actions are okay in this example. I'm switching to the design situations. The design situation serviceability limit state frequent is not required here in my example, so I can delete this one, and I will do the design checks just with the characteristics and the quasi-permanent design situations. One change is that I will create load combinations according first order analysis, so I'm switching that here and switching to the action combinations, and then if I click on this tab, I will get the result combinations, and they are all according first order analysis. Okay, that are my load combinations for this example, and now I can start filling these load cases with loads. So the first load case, dead load, will have 1.5 kilonewton per square meter on surface number 1, and it looks like this. Here in the second load case, it's now a little bit more problematic. For the live load, I would like to use a loading pattern according to this grid, to these fields here. Currently, we do not have a load wizard for this, so I will create the loading pattern by using three surface loads, rectangular loads, and polygon loads. For this situation here, so I'm in my load case 2, and I will create a rectangular load on the surface number 1. The load value is here in my example 3.8 kilonewton per square meter, and the location here is from that point to that point. And I can click on apply next. And then I see here the load in this field. And now I just entering the surface and switching the location once again. Looks like this. Apply next. 1 and here on this point. And okay. So in this situation here and in this situation, it's a little bit more complicated. So I cannot use the rectangle one. I will use the polygon load here. It's also assigned to surface number 1. And then from this point to that one, and that one, confirm with OK. The load value is also 3.8. OK, and then I need this function once again. And now from here to these nodes. OK. And it looks like this. So now I switch to the next load case. And I'm starting once again with the rectangle. 3.8. Here. Apply next. Here. Apply next. Here and OK. And then I'm switching to this rectangle once again, or to this polygon load here, from that point to that and that point. OK. 3.8. OK. For the live load 3, I'm using the rectangle again. Surface number 1, 3.8 kilonewton per square meter. And it's from here to here. And then I can click also here, apply next. And then I can switch here the load case in this dialog, assign it to surface number 1 again, and switch the nodes. And then it would look like this. If I'm entering these loads like this, then I'm always starting a short calculation progress. So I'm going to calculate. I'm just selecting the load cases where I have assigned 3 loads. Start the calculation. And now what I'm always doing here is I'm switching on the load distribution here in RFEM. I'm switching off the load here itself, but just the 2D elements. So now I can switch to all load cases and just check whether the 3 loads were applied correctly. So I have here my 3.83 kilonewton per square meter, so I can directly control the loading pattern here. Okay, that looks okay so far. So we have entered our combinations and also our loading. And now I can basically start with the first calculation for in the concrete design add-on. Therefore, I'm switching here in the table to the add-on concrete design, and by default all objects are activated here, but I will do the first attempt here just for the surface number 1. And then I'm starting the calculation. It takes a moment, and then the program will show us the design checks for the surface number 1, and we can check the design ratios at first for the ultimate limit state. And then we can check where we have to enter additional reinforcement. Okay, so basically if you do surface design, this dialog will in most cases look like this or similar. So you have several points where it's not designable or you have not designable nodes. Therefore, I would switch over here to this design checks on surfaces. And in my case, I would like to check it, for example, for the top side in direction 1. And then it looks like this, that especially over the columns, I have elements where my design checks are not fulfilled. So here you see it, it's a range from 1 to almost 3 times not fulfilled design checks. That's the same also in the other direction. And on the bottom side, it looks a little bit better, but yeah, there's also a small problem here in this area. So if I have this result diagram in this way, then I can also switch to the reinforcement. So on the reinforcement, I can switch on the reinforcement, the required longitudinal reinforcement on the top side. And then I see these values here. And one more informative graphic would maybe switching over to not covered reinforcement. So we have assigned here a basic reinforcement of 5.24 square centimeters per meters, and now it would be interesting where I have to assign additional reinforcement, and therefore I'm switching over to this not covered reinforcement. And that is, like I said before, basically over the columns, and here in the middle of the beam there's also one area where I would need additional reinforcement. Now if I'm entering additional reinforcements, there we have a new feature, and therefore I'm switching here in the data navigator to the types for concrete design, surface reinforcement, and I create a new surface reinforcement. This new surface reinforcement will be also assigned to surface number 1, but now not on the total surface, but it will be changed here in my case to a free rectangular location type. The first additional reinforcement, I will assign them just on the top side, and I will enter here a additional offset of 20 millimeters here. And I will use this additional reinforcement in both directions. And the location will be here, for example, on this point. And the dimensions are 2 by 2 meters. And just clicking here on apply. No, not yet. So, we'll enter it once again. Millimeters, okay. On this point, and 2 by 2 meters, okay. So as I said before, there is now a new option here regarding determined and buttons to overtake a determined value. And these buttons are required for a new function in RFEM 6. And you can find this new function if you click here on this button. Once in the diameter, it's called auto, and also in the spacing. So what you can do here now is you can assign an additional reinforcement, which is covering automatically the not covered reinforcement from the first calculation. So in my case, I'm needing here a additional reinforcement of around about 10 square centimeters per meter. And I can say that I would like to use rebars in both directions with 12 millimeters. And the spacing between the rebars, the spacing should be determined automatically. So if I'm selecting auto, then the program shows me these additional parameters, and there's the minimum spacing and the maximum spacing defined here. So I will use 10 centimeter as minimum and 30 as maximum, and confirming this with OK. It's the same in this other direction. OK. I click on apply. So the next is that I'm copying this one here. Copy, and I just change the location. So that is basically the same like I've done it before with the surface result adjustments. This one, and OK. And the last one will be here. Okay, and the last one is just in direction 1. I will use 10 millimeters here, but this time on the top and bottom side, this way. Also auto, OK. I can click on OK. And it looks like this. So now I have just go to concrete design. OK, so results, just delete the results here. And now, due to the definition of this slab, due to the definition of this additional reinforcement here, I've just forgotten to assign this to surface number 1. That was the problem. Okay, now it's assigned, and if I switch them off here, or switch the display setting on, then you see here on these slabs this additional reinforcement. It looks like this, and due to the fact that we now in this state do not know which value there is assigned, we have just the info that it's auto reinforcement. So with these settings, I can start the calculation once again. And now the program will cover all the not covered reinforcement automatically, and the result will be that I'm getting an info about the spacing I have to use if I assign, for example, a diameter of 12 millimeter or 10 millimeter and so on. Maybe one point which I have not mentioned yet is that you cannot assign the auto function in diameter and spacing at the same time, so that is not possible. You have to use either the automatic function for the diameter or the spacing. Okay, just wait a moment. And now it looks like this. So what you see now here is we are still in the results with the not covered reinforcement. So you see now here that the not covered reinforcement is now 0 here. It's just, if I'm switching over here, one small part, it's 0.7 square centimeters, so I will neglect it here for this part. But the other, on the other sides, it's also everything covered. And now you see here the info with the required or assigned additional reinforcement, so the value in square centimeters per meter. And if you would like to see the spacing, then you have one option. You can go to the reinforcement on surfaces and to the tab here in the table surface reinforcement. And if you click on one item, then this line or this item here also in the table will be highlighted. And in this case, I see that I have to assign at least additional reinforcement of 12 millimeter and a spacing of 11. So maybe you think that spacing of 11 centimeters is not so practical, so you can also use other values. So if I'm opening the button, the dialog for edit reinforcement once again, you have now two options basically. One would be that before you start the auto process, you can switch the increment in this additional parameter settings so that you, for example, use just 5 centimeters. That would be an option. But you can also use now this determined value here and overtake this here in this cell, and then you can edit it. So I could overtake this value and modify it, for example, to 10 centimeters. That's one option using this button here. It's also possible to select all items here which have this auto setting here. And then you can use the same button here at the bottom end, and then the program uses the automatically determined values here. Okay, I can assign this one, and I will delete the values just for concrete design. And before I'm starting the next calculation process, I will continue with the columns. So for the columns, with the columns, I will show you two new features. One would be regarding the multi-edit. So in case you have a member with a different type of reinforcement layout. So let's say, for example, in this member, I would assign 8 rebars with a diameter of 12 millimeter. It would look like this. So here we have our 4 rebars with 14, and here 8 with 12 millimeters. In the previous versions, we had the limitation that if you had different reinforcement proposals, then it was not possible to do here changes in the shear reinforcement and longitudinal reinforcement. And that is also solved now, this little downside, because now it's also possible to show here members with different settings. So you see, for example, that we have here the same rebar type, uniforms are running, but here we have a different number of bars, so from 4 to 8, and also different spacing. And here in this dialogues, there is basically a certain member displayed of the selection. So if you would like to see another member, then you can switch here with this option between the members, and then you would see the rendering for the selected member here. What I can now do here with this new function is that I can put several different members into one selection and change the reinforcement for all these members in one step. So I would set it back to 4 rebars with 40 millimeters, and then it's the same for both, and I will get also the name or the description of the item back to, because it's clear the amount of rebars and the diameter. Okay, that's basically regarding the multi-edit. So you have this multi-edit for the shear reinforcement and also for the longitudinal reinforcement. In my case, it's also the same length, but it's also possible to use this multi-edit if the lengths of the members differ. So the next feature or option I would like to show you is using member representatives for the design in concrete design add-on. Therefore, I will create types of columns. So let's say you have a lot of columns in your structure and you would do the calculation with different types. Then you can create, for example, here or not create, but enter here a comment. Let's say in my case, type 1 column, type 1, this one. And the other 4, I would add a comment and say type 2, for example. So the next step would be activate the member representatives in the base data dialog here. And if you switch or activate this member representative wizard, then you have here the option to also consider here these comments. So I'm activating these comments here. And then if I click on OK, I'm getting here these member representatives. So we have one member representative, this with the blue bubbles here, and one with this green one. And I can maybe do a double click on it. And I could directly here switch the name also in type 1 column, apply, and this one maybe to type 2. So it's not required to change it, but it maybe helps you afterwards in a documentation, because if you can afterwards also create printout reports and tables for the printout reports, including the name, and then it's maybe easier to document the results for the individual types for the column. Okay, so what you now see is also that if you are working with these member representatives, then you can now also assign here shear reinforcement, longitudinal reinforcement, and in general set all the design properties by using the member representatives. Okay, I'm confirming this with OK. And now you see here in the table with the input data, this member representatives. In my example, I would like to do the design just for the type 2 and type 1 column. I will do the design for the member here. This one, OK. And then I will activate all my punching points here in the table, but I have to activate them also here in the structure. So this one, and this one. It's for nodes, and I will activate here the punching design check. And in the configuration for punching, I'm switching here this option that I would like to use the provided longitudinal reinforcement. So as I said before, I have used here this auto function to create this additional reinforcement, and I will now also use this provided additional longitudinal reinforcement here for the determination of the punching shear capacity. Okay. That's basically all. I can now just save this file, and then we can start the calculation here for the whole structure, but I will just switch off the types for concrete design, and then I'm starting the calculation process. And in the meantime, I'm switching over to the presentation. So in the meantime, when the program is calculating, I will just give you a brief overview about the upcoming new features in our add-on for concrete design in RFEM 6. And that is a random list, so it does not mean that the first mentioned feature will be released. It's just randomly listed. So the same determination of required reinforcement, like I have shown to you for the members. So with the option in the SLS configuration, we are also developing the same option for the surfaces. Then nonlinear calculation is also in development for ultimate limit state and serviceability limit state for slabs and members or beams. Then one upcoming feature is also the merge of the shear and the punching shear resistance and reinforcement, design checks and reinforcement into one graphic. Then, of course, fire resistance design checks, seismic design of concrete components according Eurocode 8. Then we are developing an interface between our section and RFEM 6, also to have the option to reinforce general cross-section, general massive cross-sections in our sections, or on our section, not just in terms of longitudinal reinforcement, but also regarding stirrups. So you can, or you will be able in future to create free-form stirrups in our section and then import this cross-section to RFEM 6 and do the design check in RFEM 6. One open topic is also design of steel fiber reinforced concrete. Then the same function like we have seen now for the surface is with the automatic function. We are developing this for the members. And yeah, in context to the Eurocode 8 design checks, we will have also multi-legged stirrup, not just in Z direction, but also in the Y direction, so in both cross-section axes, and fatigue design according to Eurocode 2 is also in development. Like I said before, it's just a random list, so the list here of this feature is not in context to any release dates. I will switch now over to the RFEM back, and we can just do a quick overview of the results, because there we have also some new features. Just one for the members. So I have done here the design on the member here. Just for this RIP, I've just used one member here, and this is this RIP member, and there we have for example, if I'm switching over here this one and showing you just the design check for the shear force, then since some version we have extended here the amount of intermediate results, so it's a little bit much more, I would say, detailed now than before in the previous versions. So you have just to click on this small arrow here, and then you get more detailed results. Here you see the results for the new features regarding the shear joint. So that is all listed in the design checks for the members. Then if I switch over to the member representatives, it's basically the same, but what I would like to show you is if you do the design here in the add-on with the member representatives, then you will get the same result for the individual member representative. So I have here 4 columns, and the 4 columns have the same results. If you would have the individual results for the individual columns, then you can use, as I said before, the representative for input, and you have to design then the individual members, not the member representatives. Okay, then regarding the surfaces, we checked the results before. I would like to show you one last new feature regarding the punching, because in the latest version we now also implemented this load increasing factor beta that is now also possible to activate here in this detailed result. So under the design checks on nodes, you find here this load increasing factor beta. If I'm switching over to the reinforcement, then I'm switching to the reinforcement on nodes. If you have activated the required punching reinforcement here, then you can click on isolines, and by activating here values on surfaces, you will get the individual amount of required punching reinforcement here in the individual perimeters. And now, and that's the last feature I would like to show you, you have here the option in the notes to also display the outermost control parameter here. And that is also connection to that feature which I mentioned before in the presentation, that we plan to combine the results of design check for shear force in the slab and also punching shear above these columns. Okay, that are basically the mentioned new features in RFEM 6 and its add-on concrete design. And with that, I would hand over the screen back to Andreas.
Okay, Paul, thank you for this nice presentation. For this good overview, what is the current state for the concrete design in our program, and the outlook in the future. We promise to develop our programs continuously, also in the future. You will see it in the next webinar, approximately in half a year. It's already planned. Before we close the webinar, I would like to show my screen to show you where I can find the recording and the provided model. Under dlubal.com, you can find under news and events the webinars, where are the already planned webinars and the accomplished webinars. That's today's webinar. I click on it. But you will also get an email in the next days with a link to that page here, and then you will find the recording here in the middle. The PowerPoint slides are already there, and above you can download the model that Paul showed today. If you don't already use RFEM 6 and you would like to try, for example, the webinar or other things, then feel free to download the free trial version of RFEM 6 or RSTAB 9. That's only for members. You can try the versions with all add-ons for 90 days. Just do it, for example, with the model of today's webinar. Okay, then I say thank you for your attention. Thanks to Paul for this nice presentation. Thanks to Alexander and Adrian for answering the questions. Maybe a last hint when you leave the webinar, where is a small survey. It takes you only 1 minute, I think. You can score us. Just note that the worst score is 1 and the best score is 5. You can enter what you wish for future webinars. You can leave it empty as you want. Okay, then have a nice day and bye-bye.